Good evening, engineer Sahoner. I'm going to present the video summary with 3 post videos. The first video introduces us to causal loops, also known as feedback loops. These loops are visual representations that show how parts of a system influence each other cyclically. Causal loops help us understand the dynamics within a system beyond linear cause and effect relationships. There are two main types of causal loops. Reinforcing loop. In this type of loop, the elements of the system continue moving in the same direction, either increasing or decreasing, so as a band balance that grows due to accumulated interest. Balancing loop. Here the system seeks equilibrium, oscillating between different states, like when increased stress leads to more coping strategies, which in turn reduce stress. Causal loops are essential for analyzing complex problems and seeing how the effects of our action perpetuate in a continuous cycle. The second video shows us how to create cause and effect diagrams, also known as Ishikawa or fishbone diagrams. These diagrams are tools for breaking down complex problems into fundamental causes. The process for creating a cause and effect diagram is as follows. First, define the problem, write the effect or problem in a box. Second, draw the main spine. Draw a horizontal line representing the backbone of the diagram. Third, identify categories. Select main categories such as people, method, materials, equipment, and environment. Fourth, list the causes. Identify possible causes for each category and connect them to the main spin. The third video explains the importance of causal diagrams in the fight against climate change. These diagrams are fundamental because they allow us to identify and modify interconnection within a system. Benefits of causal diagrams: understanding interconnections, clarifying strategies, and identifies alliances. These diagrams are strategic tools essential for addressing global issues like climate change. The fourth video introduces us to causal graphs, also known as direct acyclic graphs. These graphs are visual representations used to model data in causal context. Key concepts: nodes and edges. Nodes represent variables, and edges indicate causal relationships between them. Direct graphs: all edges have a directions modeling the flow of time. Cycle and acyclic graphs: an acyclic graph has no cycles, ensuring that time does not stop occur. These graphs function as statistical models that help estimate causal effects with precision, capturing the complexity of many systems. And now, with the big by week readings, chapter 6, causal diagrams. Objective of the chapter focuses on the introduction and use of causal diagrams to present data generating processes. These diagrams help understand and analyze causal relationships between variables in a system. Chapter 7, Drawing Causal Diagrams. Objective of the chapter focuses on how to draw causal diagrams and use them to identify causal paths and avoid biases analysis. And the key points of the chapter are constructing diagrams, guidelines for correctly identifying and representing causal relationships, causal paths and backdoor paths, how paths in a diagram can show direct and indirect effects, and how to handle biases. Example of causal paths, example for identifying and controlling these paths in diagrams. project progress. In terms of the progress on my computer vision project, the scope of the system has been defined. The main objective is for the system to recognize three specific situations where the bands of electric machines are covered, when employees are talking, and when they are working. These objectives will improve safety and efficiency in the workplace, ensuring that machines operate correctly and that staff remain focused on their task.